So in class, we talked about finding limits or graphically. Today, this video is going to be finding limits algebraically. So how do we find the limit if we're given a function instead of a graph? So the first thing is the limit of a constant. So if you think about a constant, what this means is that my function is equal to 5. So the other way to write it is like y equals 5. And if you remember, y equals 5 means y is always 5. So that would be a horizontal line at y equals 5. So at any x value that I approach, so if I'm looking at the limit as x approaches 1, that approaches both from the left and from the right the y value of 5. So when we do a limit of a constant, it's always just whatever that constant is. Okay, and a constant is just a number. So the limit as x approaches 1 of 5 would just be 5 because the y value is always 5 for every point on this graph. The same thing would be for this. Pi is just a number. It's like 3.1415. It keeps going on. And so that graph would look like a horizontal line at 3.14, so like around here. And so at x equals 3, the y value would just be what this y value is, which is pi. So the limit of a constant, if it's just a number, is itself. Now, if we have the identity function, which is x, what we do is if it's just a variable, we can just plug in that x value. We can substitute. So the line, this represents y equals x. Like this is my function. It would be the value, the y value would be x. And so that one is like if x is 1, y is the same thing, 1. If x is 2, y is 2. If x is 0, y is 0. If x is -1, y is -1. And so this is just this diagonal line through 0, 0. And so if I went to x approaches 1, it would just be the y value of 1. So what you can do is if it's any variable, you can just plug in this x value for it and then simplify, and that gives you what the limit is. So the limit as x approaches 1 of x would just be 1. Okay, and we're going to use that method a lot. So the first thing, if we have a function, like this would be my function, 3x squared minus 2x plus 1, the first way to evaluate limits is just to plug in that x value for every x that you see and simplify. And as long as we get some number out, that's what the limit would look like, or that's what the limit would equal. So for this one, what I'm going to do is I want the limit as x approaches 2 of this function, 3x squared minus 2x plus 1. And so I am just going to substitute in the x value of 2 into my function because this function is going to be continuous. So the y value is going to equal the same value as the limit. And then we just simplify. So just make sure you can either type it all in your TI at one time, or if not, you do order of operations. So you do exponents first. 2 squared is 4. Then I would do the multiply. So 3 times 4 is 12. And then I have 2 times 2, which is 4. And then 12 minus 4 is 8, plus 1 is 9. Like I said, you can just use the TI. It's probably easier or faster to just type it all in. So it'd be 3, and then you'd put parentheses, 2, and then here's the squared key, minus 2 times 2 plus 1, and just hit equals, and it'll give it to you. Okay, so this is the same idea. We just first see if the limit exists by just plugging in the value for our x. So I'd have the square root of 5 times 1 plus 4. And so I'd have the square root of 5 times 1 is 5, plus 4 is 9, and then the square root of 9 is 3. So this limit would equal 3. Okay, and the same thing, you could just type it in again. The square root is if you hit second, and then this, here's the square root in blue, you hit that. And then you would press 5 times 1 plus 4. And you get 3. Okay, and the reason is just if I graph one of these. Okay, so if I go to y equals, I can graph them. So if I graph my first function, 3x squared minus 2x plus 1, and hit graph. Okay, you can see it's kind of this parabola, and it's a continuous function. So if I look at 2, you can hit, let me make this bigger. This button, trace, and trace it, and you can see as x gets closer to 2, my y value is getting closer to that 9. And what you could also do is type in, you hit second calc and then hit enter for value and type in x equals 2, it will give you the value y equals 9. Okay, now you're supposed to do these algebraically and not using the graph, but this is just to show you that if I have a continuous function, we can just plug in that x value, and the limit will be the same thing as what the y value is when I plug in that x value into this function. So that's the first method that you should always try, but sometimes we will run into problems when we do that method. So sometimes when you plug in a number, you're going to get 0 over 0, and this is called an indeterminate form, which means I don't know the limit right now. Like I can't find the limit just by substituting it in. If that happens, it usually means the graph has like a hole there where the point doesn't exist. And so what we can do to figure out what the value is that we can kind of simplify the function in order to get rid of that hole. And so what we do is we're going to simplify by factoring, and then we'll do direct substitution. So you should always first try like substituting. So if I were to do that, here I would get 3 squared minus 9. Okay, and 3 squared is 9 minus 9, which is 0, over, and I have to plug it in for the denominator too. So 3 squared minus 10 times 3 plus 21. And I'm just going to plug that, just to be fast with it, is plug that in the calculator. So I'd have 3 squared, let me get out of the graph menu. So I'd have 3 squared minus 10 times 3 plus 21. Okay, and if I do that, I also get 0. Okay, and so this is giving me, when I plug it in, 0 over 0. Okay, which doesn't tell me anything. I don't know what the limit is. So if that happens, what you're going to do is you're going to factor anything you can and simplify. So anytime you're factoring and you're not plugging in your x value, you have to write the LIM notation every time. So I'm going to factor x squared minus 9. Now this is called the difference of squares. It's like the a squared minus b squared. And that always factors to a so this factors to a plus b and then a minus b. Okay, and so a is the value you were squaring to get this number. So like for this one, I have x squared minus 9. Okay, so you would have x would be what your a is. So you'd have x here and x here. And then we're saying, okay, what squared gives me 9? Or the other way to find b is you can just take the square root of this number. So the square root of 9, which is 3. Okay, because 3 squared gives me 9. So what I would be doing is I would get x plus 3 and then x minus 3. That's how it factors. And then the denominator, so when you have 3 terms and the first term is just x squared, when we factor this, we figure out what multiplies to the last number and adds up to the middle. So I want what multiplies, if I do it on the side, what multiplies to to positive 21, and I want it to add to a negative 10. Okay, and some people are really good at guessing this right away, and other people, it might take a few tries. But if I think about 21, okay, what multiplies to it? Well, 7 times 3. But if I add 7 and 3, I would get a positive 10. But if I make them both negative, a negative times a negative gives me a positive, and negative 7 plus negative 3 gives me a negative 10. So then what we do is we put x and x in the first spot because x times x gives me x squared, and I put these two numbers in my second one. So it'd be minus 7 and minus 3. Okay, and you can always check it by doing like FOIL or first, outer, inner, last to make sure that you get this when you do it. So like I have x times x, which is x squared. I have outer, which is negative 3x, inner, which is negative 7x, and then last, negative 7 times negative 3 is 21. Well, then my negative 7x and negative 3x adds up to negative 10. So it works. So once you do that, what should happen is you should have a common term. If you don't, you probably factored incorrectly because most of the time you'll have a common term. And so these common terms reduce or cancel. And so this expression is the same thing as x plus 3 over x minus 7. And so when that happens, what it means is that at x equals 3, there was a hole, that this y value does not exist for the original function. But the limit will exist because we don't care about what happens at the y value. We just care if it approaches the same value from the left and to the right. So once I get it simplified, I can directly substitute. And when I substitute, I don't put the limit sign anymore. And so then I get 3 plus 3, which is 6, and 3 minus 7, which is negative 4. Okay, and 6 divided by negative 4 is negative 1.5 or 3 over 2. Either way is fine. And so that would be my limit. And so I don't know exactly, I guess we can graph it. This graph looks like, but what is going to happen is you're going to have a hole at that point. So if I graph this, I'm going to have x squared minus 9, and then x squared All right, let's try that again. So x squared minus 10x plus 21. And if I'm dividing by multiple terms, I need to put them all in parentheses. If I graph this, it looks like that. Okay, I'm looking at x equals 3. So it's kind of hard to tell on these because it looks like there's a y value there. And if I zoom in, they still show you a y value. But if I go to second calc and hit value and type in 3, it's going to give me a blank. It's going to give me an error because that point doesn't exist. Your calculator is not really good at showing holes. The other thing, if I hit second table, and if you look at the y values at 3, there's an error. So what that means is that there's a hole there. Like I said, it's really hard to tell using the graphing calculators, but that would be a hole there. So this is the limit. Okay, so what you do if you get 0 over 0, you factor, you cancel the common term, and then you plug in your x value and simplify. Okay, so let's look at this second one. I'll move it down here so we have more room. And I kind of did for this one a little bit trickier than you normally will have to for factoring. But like if we look at this one, if I plug in 1 initially, I would get 1 cubed minus 1, which is 1 minus 1, which is 0, and 1 squared minus 1. So 1 minus 1 again, which is 0. So again, this is called an indeterminate form. It does not mean it equals 0. It does not mean it does not exist. It means I have to do more work. Okay, so what I have to do is I need to factor the numerator and the denominator. So I don't know if you've seen this type before, but the top is called the difference of cubes. And you won't really have to know this one, this factoring. I don't think it comes up other than here. But for the difference of cubes, when you factor it a cubed minus b cubed, what it is it's a minus b, and then it factors to a squared plus ab plus b squared. That's how it factors. So your a is kind of the cube root of the first term, and your b is the cube root of the second term. So for this one, my a cubed is x cubed. So a would just equal x. And my b cubed is 1. And so my b would be 1 because the cube root of 1 is 1. Like what times itself 3 times gives you 1. So if I were to factor this, I would get a minus b, which would be x minus 1. A squared, so a is x, so that would just be x squared minus a times b, so it would be x times 1, which is just x, plus b squared, which is 1 squared, which is 1. So that's what it factors to. The denominator is what we did, the difference of squares. This comes up a lot, so you do need to know how to factor that. So this again is the 2 sets of parentheses. The first spot is x and x, because x times x is x squared. The second spot is 1 and 1, because 1 times 1 is 1. And then one of them is plus and one is minus. The order doesn't matter. So again, you should have a common term, which I do, the x minus 1. So those cancel. So this is the same thing simplified as x squared minus x plus 1 over x plus 1. And then you just plug in the 1. So you get 1 squared minus 1 plus 1. And 1 plus 1. So this top gives me 1 minus 1, which is 0, plus 1, which is 1. 1 plus 1 is 2. So the limit is 1/2 or 0.5. And that's what this limit is equal to. So that's how you simplify limits algebraically. And there's one other type. There's a type called the infinite form. So if you plug in a value and you get a number that's not 0 over 0, where a is a number, I should put here, not equal to 0. This is called the infinite form. And if that happens, the limit does not exist. What that means is there's an asymptote at that, a vertical asymptote at that point. And I guess I'll graph it on here again. So y equals 2 divided by x minus 2. I gotta zoom out so we can see that. So what that means is that 2, there's gonna be like an asymptote where the curve is the y values approaching like really high up, which is infinity, or really far down, which is negative infinity. It keeps going on forever. And so we say that limit does not exist. So anytime you get a number that's not equal to 0 over 0, it's called the infinite form, and we say the limit does not exist. So like for this one, if I would plug it in, I'd get 2 over 2 minus 2. So I'd get 2 over 0. And for this limit, we would say does not exist. Right, and here's kind of 3 more that are like that. We'll just do the first one. If I plug in 0, I get 3 times 0, which is 0 minus 1, negative 1, over 2 times 0, which is 0. And then anytime I get a number that's not 0 over 0, we say it does not exist. It's the infinite form. And all of these kind of work out like this. So this one is 2 times 3 plus 3 over 3 minus 3. So I would get 9 over 0. So again, this limit does not exist. So this third one is going to turn out to the same, but just be careful. Okay, a number over 0 gives us does not exist, but if you get 0 over 0, that's where you have to factor and cancel. So that's how you find limits algebraically.